Okay, here we go with some section 2.1 review problems. And using the procedure laid out like in the first homework problem of the section 2.1 homework, I say find all of the x intercepts. To find the x intercepts, we let y equals 0 and solve this equation. 0 equals 0.5x times x squared minus 9. So to solve this, we factor that difference of squares. So now we have the equation factored equal to 0. By the zero product rule, let each factor equal 0. 0.5x equals 0. Divide both sides by 0.5. We get x equals 0. X plus 3 equals 0. Gives us x equal -3, and x minus 3 equals 0 gives us x equals 3. And for each of those values, they match up to the y value of y equals 0. So that gives us our 3 x intercepts. And what I've done here is I've put those intercepts in an xy table, and I've also plotted them on the graph. And as you can see, they all lie in a line because they're all on the x-axis. That just tells us where that graph crosses the x-axis. It cannot cross the x-axis in any more points. We found them all. So now we have to find some more points in between those intercepts and maybe to the far left and to the far right to see what this graph is doing. So in between 0 and 3, if we let x equal 2, plug it into our equation, 2 times 0.5 is 1, 2 squared is 4 minus 5, -5 times 1 is -5. When we plug in -2, we get -1 times -5, which is +5. So that gives us a couple more points. 2, -1, 2, 3, 4, 5 down here. -2, +5, 1, 2, 3, 4, 5 up here. So that gives us the graph in the middle. It's going up, coming back down, passing through 0, going up. And now just a couple more points at x equal 4 and -4. If we plug in 4 times 0.5 is 2. 4 squared is 16 minus 9 is 7. 2 times 7 is +14. And -4 gives you -14. So the graph's going way up here. I have 14 up here on my graph. Down here, it's off the graph a little on the left side. Just barely off the graph, or right on the border of the graph. So that gives us the far left behavior and the far right behavior. And there's our graph. Okay, in the next problem, a circle has center 1, -2 and contains the point 3, 4. Find the radius of the circle and the equation of the circle. Well, to find the radius, you use the distance formula, the distance from that center to that point on the circle. So we use this distance formula, d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And really what that is an application of the Pythagorean theorem. If you go to the notes, you'll see how that is shown and explained. So we plug in those x values, 3 minus 1, and 4 minus a -2. And so we get a distance of the square root of 2 squared plus 6 squared, which is square root of 4 plus 36, square root of 40. So that distance is the radius of the circle. That's the distance from the center to any point on the circle. So now we plug that radius and the given center into the standard form. So our standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. And that also is derived using the distance formula, which is the Pythagorean theorem. And you can look in the notes for that explanation. But we have our h and k. H is 1, k is negative 2, so it's x minus 1, y minus negative 2. And our r here is the square root of 40, and that's what we're squaring. So when we simplify this, we get x minus 1 quantity squared plus y plus 2 quantity squared. And the square root of 40 squared is 40. So don't forget to square that square root and change your negative sign. Okay, in the next problem, a circle contains a diameter with endpoints 1, 3, and 3, 5. Find its equation. And students often don't know how to start this, so let's look at the graph of this circle that has these endpoints of a diameter. So if we graph this circle, we have these endpoints of a diameter 1, 3, and 3, 5, and the diameter cuts right through the middle of the circle. So the midpoint of those 2 points will be the center. So the center equals the midpoint. So find the midpoint, and there's a formula in your notes that basically summarizes the midpoint formula as the average x value and the average y value. And when we use that midpoint formula, we have x1 plus x2 divided by 2. That's the average of the two. y1 plus y2 divided by 2, the average of the two y values. Add them up and divide by 2. So we get a midpoint of 2, 4, which from our graph is right about where it appears to be, 2, 4. So that's our center. So now we have a problem like the previous problem. There's actually 3 ways you can go to find the radius. 3, I'm not kidding, 3. You can find the distance of that diameter by finding the distance from 1, 3 to 3, 5, but then divide the answer in half, because the radius is only half of that. Or you can find the distance from 2, 4 to 1, 3, or you can find the distance from 2, 4 to 3, 5. Those will all give you the same radius. What I'm showing all 3 methods here. We can find the radius by taking the distance from 2, 4 to 5, 3, get square root of 2. We can find the distance or the radius by taking the distance from 2, 4 to 1, 3, square root of 2. Or if we find the diameter, the distance from diameter endpoint to endpoint, we get the square root of 8, which is 2 square roots of 2, but when we divide it by 2, we get square root of 2. So all 3 of those methods give you the square root of 2. Now we have enough to find the equation because we have the center, it's 2, 4, and we have the radius. So off in the left-hand corner here, I finish this problem. We use this standard form, x minus h quantity squared plus y minus k quantity squared equals r squared. Plug in 2, 4 for the h and k. Plug in our square root of 2 for radius. And we get the simplified form of x minus 2 quantity squared plus y minus 4 quantity squared equals 2. Okay, in our last problem for this section, we have a circle, x squared plus y squared plus 6x plus 2y plus 1 equals 0. Find its standard form and then indicate the center and radius of this circle. So what we're going to do is get those x terms grouped together, get the y terms grouped together, move the 1 over to the other side of the equal sign as negative 1. So we start doing that, x squared plus 6x plus y squared plus 2y. subtract 1 on both sides to get negative 1. Okay, now, if only these two groups were perfect squares, we would then have x plus something quantity squared, y plus or minus something quantity squared, and then we could rewrite this. So we have to complete the square on both the x and the y group. So we use that completing the square procedure we learned, back in section 1.3. Half of the coefficient on x is half of 6 is 3. 3 squared is 9. We add 9 to the x group. Now if we add 9 to the left side of the equation, we also add it to the right side. In the y group, half of 2 is 1. 1 squared is 1. We add 1 to both sides, the y group and the right side. Now we simplify this a bit. So we simplify the right-hand side, and then we factor both the x and the y groups. The x group factors as x plus 3 quantity squared. The y group factors as y plus 1 quantity squared. And we have that equal to 9. Now, equating this to the standard form, x minus h squared plus y minus k quantity squared equals r squared, we find that h has to be negative 3, because it's x minus a negative 3 to make the x plus 3. K has to equal a negative 1. And r is not 9, but r is 3 in this case, the square root of 9. So we get a center of negative 3, negative 1, and the radius of 3. Okay, and that's it for the 2.1 review.